The topic of my speech today is the welding of metals for industrial purposes. The purpose of the speech is to educate you on the importance of structurally sound welds and the necessary procedures in order to produce them. A structurally sound weld is of paramount importance in every industry that involves welding, from transportation, planes, trains, automobiles, to construction, oil and gas, food, pulp and paper, chemical, pharmaceutical industries, and numerous others. Really, your very survival places reliance in the assumption that the welds you encounter in daily life are sound and will hold together in numerous environments. Whether it's the plane you're riding in, or the car you're driving, the pipeline that's running underneath you, the food that's processed with the welds that are done on piping in the food and milk industry or beverage industry. Numerous different areas that really rely on having sound welds. They need to be able to hold together without any failure or catastrophic results can take place. The ability to join two pieces of metal together really dates way back to the Bronze Age, probably, or at least the Bronze Age and the Iron Age for iron. But really, the type of welding I'm going to focus on today was developed in the mid 1800s, and it's a weld produced with an electric arc using electricity. So it's come about since the invention of electricity. And there's numerous different types of welding. The three most common are the ones I'm going to focus on today, and they are stick welding, which is stick metal arc welding, TIG welding, which is gas metal arc welding, and take that back. TIG welding, which is gas tungsten arc welding, and MIG welding, which is gas metal arc welding. Not that means anything to you now, but I'm about to explain this to you. So each method accomplishes the same means, which is to join the metal together, and each involves its own process, procedure, and technique. So I'll start with MIG. This is the most common type of welding. Its official name is really gas metal arc welding. It involves a spool of wire and a wire feeder and a power source. You pull a trigger and it pulls that spool of wire, and pretty much what happens, that wire comes out and hits two pieces of metal you're trying to join together, say in a T-joint, and you'll point that gun in the direction of those two pieces of metal, pull the trigger, the metal comes out, creates a resistance, an electrical arc that melts both the base metals and that roll of wire and produces a puddle of molten metal, which is the weld bead. And as that metal continues to come out, it keeps melting and melting and remelting and makes a bead. And you need a shielding gas to keep that, while that metal is molten, it needs to be shielded from atmospheric contaminants, nitrogen, oxygen, whatever's in the air. It needs to be kept pure metal. And if it doesn't have that shielding gas, which is an inert gas, argon, shrouding it while it's molten, it'll bubble like porosity. It'll look like pumice. Porosity, basically. It won't be a strong weld. So you have to have the shielding gas along with that. And the advantages of this type of welding is it's real easy. It's quick deposition rate. It's used in automotive industry, construction, all over the place. It's the most common type of welding done today. The disadvantages of it are that it is prone to atmospheric contamination. So if you don't have that shielding gas or good shielding gas, that weld will not be sound. So it's critical that it is. So another type of welding is stick welding, which is stick metal arc welding. It's also an electrode welding, which uses a consumable electrode. In this case, instead of a spool of wire, it's a rod. It's about an 1/8 inch rod with that's coated in flux. And that flux takes the place of the shielding gas. In this case, when you strike the arc or you strike the welding rod against the metal you're welding, it creates the arc, and the resistance to heat melts the metal, and that flux melts with it and shrouds that molten metal with the coating, the flux coating, which is silicon or iron oxide or whatever, basically keeping that melting pure until it solidifies. This type of welding is advantageous in that it doesn't use a shielding gas. It can be done with a 50, 100-foot extension cord. Your welding leads can be 100 feet long. Your power source can be 100 feet away from you. You can be out on a bridge or in a high-rise welding on some I-beam and not have to worry about oxygen or your inert gas, argon, being carried all the way up to where you're welding. So it's used in construction. It's very common in construction and some pipe welding applications in remote areas. The disadvantage is the deposition rate is slower than MIG welding, and its cleanliness. That flux needs to be knocked off, and that's just, and then looks, it also doesn't always look as good, and really it takes more skill than MIG welding, so often that could be a disadvantage depending on the industry. Third type of welding is gas tungsten arc welding, which is also known as TIG welding. This type of welding uses a non-consumable electrode. The electrode in this case is a piece of tungsten, which is a piece of metal that has a really high melting point of around 5,000 to 6,000 degrees Fahrenheit. And pretty much that is the little piece of metal is your electrode, which is the piece that's used to make that electric arc, to melt the metal. So you'll have the tungsten electrode, which is your torch in one hand, and then some filler rod in the other hand. You melt the base metal with your TIG, with your tungsten torch, and then you're adding your filler rod into that molten puddle. And that creates the bead. I have an example of one here, actually. This is a TIG weld produced on a stainless steel pipe. There's some more TIG weld. It's a decent TIG weld. Could be better. But either way, the advantage to this is that it produces a very clean weld. It's good for supercritical environments, the pharmaceutical industry, food industry, oil and gas. If a weld needs to be x-rayed, needs to be 100% pure of any void or contamination or anything like that, often TIG welding is the go-to. Disadvantages are that it's a slower deposition rate and really requires more skill to make the weld. And also the environment has to be a clean environment and can't be done outdoors or up on a bridge or in a high-rise or something like that. So there's also various welding standards and codes written by organizations such as the ASME, American Society of Mechanical Engineers, American Welding Society, and each welding code has parameters as to how a given type of weld can be performed. Basically, each weld has a procedure that's written and allows you a certain amperage range, a voltage range, a material thickness, a material type, and that'll give the welder instructions as to how to make a weld. If he's given a piece of pipe or two pieces of pipe or fittings or something, needs to make a weld, he'll follow a weld procedure in making that weld. And that's a proven procedure that's been tested and basically tested in a lab through destructive testing to ensure that it is, those parameters can produce a sound weld. So each process, whether it's stick, MIG, or TIG, they all have their own procedures. The other thing, probably arguably the most important factor in producing a good weld is the welder himself. And the biggest thing to becoming a good welder is through practice. Practice makes perfect. A certified welder becomes certified by practicing and by being able to take certain tests that show that they can weld, upside down and backwards, and basically, depending on the type of weld test they performed, gives them the ability to produce welds in more and more stringent environments, basically. And an understanding of metallurgy is crucial. Having good vision. Typically, welding is, of course, done as it produces a really bright light. You've got to have a welding helmet to do that, actually have an example of one. This is a typical welding helmet. It's an automatic one. It'll stay light until you strike the arc and then go dark. So it's a new helmet. It's easier than the older kind. But either way, once the helmet goes dark, you need to know what you're doing, and you need to be able to. You need to have trained eyes to see how that molten puddle looks, and how you need to tilt your torch, and what kind of angle you need to, when to add your filler rod and timing and all that kind of. It takes practice, and then ultimately it is the responsibility of a welder to produce a good weld and to know that he's producing a good weld, and if he's not, he needs to take the necessary adjustments in order to produce a good weld. So basically, to sum it up, there's a whole bunch of different ways of making a good weld. The most important factors are the personnel, the welder himself. The equipment is also a key factor. Having good equipment, but really a bad carpenter blames his tools. So I'd argue the most important thing is the welder himself. Consumables, though, are another key factor in a good weld. If your consumables are old, rusted, corroded, wet, your weld's not going to be good. If your shielding gas isn't good, your weld isn't going to be good. And the environment you're in also affects the weld. As well as the procedure itself. The procedure has to be a sound, tried and tested procedure. So the next time you're in the Braves Stadium or you're in a large building with I-beams and welds, take a minute to look up at them, and where the metal butts together, look at that weld bead around there and appreciate all that goes into making that weld. That's it.